Understanding thermodynamics and applying the laws of energy conservation. 1. Introduction to thermodynamics. Definition. Thermodynamics is the study of energy and its transformations, particularly in relation to macroscopic systems. It encompasses principles governing heat, work, temperature, and the behavior of matter. 2. Laws of thermodynamics. Zeroth law. If two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. This law establishes temperature as a measure of thermal equilibrium. First law, law of energy conservation. Energy cannot be created or destroyed in an isolated system. It can only change forms. The total energy of an isolated system remains constant. Second law, the total entropy, a measure of disorder or randomness, of an isolated system tends to increase over time. It introduces the concept of irreversibility in natural processes. Third law, as the temperature of a system approaches absolute zero, the entropy approaches a minimum value. It is practically impossible to reach absolute zero in finite steps. 3. Applying the first law of thermodynamics. Energy forms. Identify the various forms of energy in a system, such as internal energy, kinetic energy, potential energy, and heat. Conservation. Recognize that the total energy of a system remains constant, but it can be transferred between the system and its surroundings as heat or work. 4. Heat and work. Heat, Q. Understand heat as the transfer of thermal energy between systems at different temperatures. Heat flows from higher to lower temperatures. Work, W. Recognize work as the transfer of energy due to a force acting over a distance. Work can be done on or by the system. 5. Internal energy. Definition. Internal energy is the sum of all microscopic kinetic and potential energies of particles within a system. First law equation. Delta U equals Q, W, where delta U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. 6. Thermodynamic processes. Isobaric, constant pressure. Isochoric, constant volume. Isothermal, constant temperature. Adiabatic, no heat exchange with the surroundings. 7. Second law of thermodynamics. Entropy, S. Understand entropy as a measure of disorder or randomness in a system. Entropy change. Delta S equals Q, T, where delta S is the change in entropy, Q is the heat added to the system, and T is the temperature. 8. Practical applications. Heat engines. Recognize that engines convert heat energy into mechanical work. The efficiency of heat engines is limited by the second law. Refrigerators and heat pumps. Understand how these devices transfer heat from a lower temperature region to a higher temperature one. Their efficiency is expressed using the coefficient of performance. 9. Energy conservation in daily life. Home heating and cooling. Apply thermodynamic principles to optimize heating and cooling systems in homes. Transportation. Understand the efficiency of engines in vehicles and the impact of energy conservation measures. Renewable energy. Explore how renewable energy sources align with the laws of thermodynamics. 10. Problem solving. Practice problems. Work on problems that involve the application of the laws of thermodynamics. Use equations to solve for unknowns and understand the relationships between variables. 11. Study material. Textbooks and online courses. Refer to textbooks on thermodynamics and take online courses to deepen your understanding. Simulation tools. Explore simulation tools that allow you to visualize thermodynamic processes and their effects. 12. Experimental understanding. Laboratory experiments. Participate in or observe laboratory experiments that demonstrate thermodynamic principles. This hands-on experience enhances conceptual understanding. 13. Real-world observations. Environmental changes. Observe how natural systems, climate, and environmental processes align with thermodynamic principles. Industrial processes. Explore how industrial processes adhere to or deviate from thermodynamic laws. 14. Stay updated. Research and developments. Stay updated on current research and advancements in thermodynamics. Explore how new technologies align with or challenge existing principles. 15. Seek guidance. Consult experts. If you encounter complex concepts or challenges, seek guidance from professors, experts, or online forums dedicated to thermodynamics. Understanding thermodynamics and applying the laws of energy conservation is a foundational aspect of physics and engineering. By delving into theoretical principles, engaging in practical applications, and staying curious about real-world phenomena, you can develop a comprehensive understanding of thermodynamics and its significance in various fields.